Hello everyone, and welcome back to another IB Math speedrun with me, Vince. So in today's speedrun, we're going to be continuing with our exploration of sine and cosine functions by looking at fitting data to a sine or a cosine function. So let's jump right in. So let's break down a sine function, and the same thing for a cosine function really. And so if we have some function that's equal to a sine bx as a b times x plus c plus d. Well, what are all these things? I mean, this is simple function transformation. A is how much we're going to horizontally stretch this. I mean vertically stretch this. But for these cosine and sine functions, we give a special name, and it's called the amplitude. It's more or less half of the range of values, or more or less the half of the maximum minus the minimum value. Next, we have the vertical shift d, which is the average value. It's like when this entire function equals 0, or what will the function be? And so this is the vertical shift. So we can find this by just averaging the maximum and minimum value. B is the period. So B is it's technically 2 pi over the period, since this is how much we're compressing the graph by. If B is 2, it means the graph is going to be compressed by 2 times. So this is equal to 2 pi over the period. And finally, the phase shift is called c. So this is how much we're shifting the graph by. So let's jump into some questions. That's pretty much it. So I'll be doing the one starting from number 1. So we have find the amplitude, period, and phase shift of each of the functions and the maximum and minimum values. And so the first function is, the only function, since I'm doing 1, is 5 sine 3 times x plus pi over 12 plus 1. So that is going to be our first function. So we need to find let's start with the amplitude. So the amplitude of this function is simply 5. It's just this number over here. So this is the amplitude, 5. Next, the phase shift is going to be pi over 12, since we're multiplying x by pi over 12. What's next? The period is, we need to look at 3. And we know that this number will be equal to 2 pi over the period. So we have the period is equal to 2 pi over 3. In other words, 2/3 pi, 120 degrees. Finally, we need to find the maximum and the minimum functions. So the maximum this part of the function is 5. So the maximum of the entire function will be 6. And the minimum that this sine function can be is -5. So -5 plus 1 is -4. So that's the minimum. And this is the maximum. So yeah. Okay, next. We have a question. The voltage V produced by an AC generator is given by 220 sine 120 pi t. So questions. What is the maximum? What is the minimum? What is the amplitude? What is the period? And sketch the graph over 2 periods. Okay. So what's the maximum of this function? The maximum of the sine function is 1, so the maximum is going to be 220. What is the minimum? The minimum of the sine function is -1, so the minimum will be -220. What is the amplitude? 220. What is the period? Okay, so inside here we have 120 pi times t. And we know the period is going to be 2 pi over 120 pi. So this will actually simply be 1 over 60. So the period will be, in this case, 1 over 60 t. So now we have to sketch the graph over 2 periods. So this looks like a standard 60 Hertz AC generator, but anyways, 220 sine, we can simply draw a normal sine graph and then label it. So what we have here is we have 1 over 30, 1 over 120. Here we have 1 over 60. Here we have 1 over, this is 3 over 120, 1 over 40. And here we have 1 over 30. So yeah, of course the peak will be 220, and the trough will be -220. No vertical shift at all. I don't know how they've got the period as 1 over 110. Perhaps they just accidentally divided the voltage by 2, but I don't see how that is. So I'm going to say they're wrong. Okay, next we have find equations for the following graphs. Okay, so our first graph looks like this. We have it's varying around the point 3, and I've drawn it wrong. So this should be a peak, that should be a trough, that should be a peak, that should be a trough. So it's this middle section is 3, and it's not going above 2 or below 4, and it has a period of 2 pi. So I would say that this equation is going to be, well, I guess we can model it as a cosine graph, technically. So let's say the amplitude is 0.5, and then we have cosine times simply x. No need to change the period, and there is no phase shift. Yeah. And then we have -3. Let's say that. Let's see, is that correct? Yeah, so we're just 1/2 cosine x minus 3. Okay. Next graph. We have a graph that looks like this. So this is this peak is pi. This peak is -pi, and of course 0. And this bottom is -4. This top is 2. Okay, so what is the model of this graph? So we need to know the vertical shift will be -1, and we can model this as a cosine graph. The amplitude is 2 minus 4, 6. So the amplitude is like 3 cosine x. But we need to manipulate this a little so that it fits, because we can see the period is 1/2 of what it should be. So we have, I think it's pi over 2. No. It would be 1/2. 2 pi over 1/2. This should be 4 pi x? No, this should just be 2x, honestly. I don't understand this book. It's not -2, it's only -1. Anyways, that's correct. And so let's move on to the final question. And the final one is, we have a tangent graph. So what do we have over here? So it intersects there. Oh, I can't draw. And there. So this point here is pi over 4. And the next point is 5 pi over 4. So this is clearly a tangent graph. And I don't see any displacement. It's just a phase shift. So this looks like, I mean, tangent of, well, is this correct? Yeah, that's correct. So this would be just the tangent of x plot x minus pi over 4 is what I think the graph is. Yeah, that's it. So that's all for the speedrun. I hope you enjoyed, and I hope to see you in the next one.